Hello, I'm Mrs. Han. I'm going to explain the hominid skull comparison activity. And what I did was I went ahead and popped that out, and I'm going to pop this one out so that I can see them side by side. And if you're using Cami Editor, then you can open this with Cami so that you can write on the dock. Okay? So gives you a little introduction. Right now we have modern day chimpanzees or apes and modern day humans right here, Homo sapiens. And then they found a bunch of skulls that sort of seem a little bit in between, that are not matching any living primates. So what you're going to do is take a look at those skulls, and here they are right here, and you're going to be comparing them to humans and chimpanzees and to see which ones are more like chimpanzees or apes and which ones are more like modern humans. So I went through it already, and it was a little confusing. So where needed, I put in some answers, and I kind of started you off on a lot of them just so that you didn't get too stressed out by the uncertainty or the confusion. So you're going to be looking at each of these skulls. There's 6 different skulls. So the first 2 are ones that are alive today. So here's human skulls, here's chimpanzee skulls. And then these, the next 4 are ones that were discovered that seem to be sort of human and maybe sort of ape-like. And so we're going to be analyzing them with different, by different characteristics. So the first thing you're going to be looking at is their cranium size. And I filled in a couple of these just so you can get the gist of it. Here, the cranium size, or the kind of the size of their brain, is 1375 milliliters for male and 1215 milliliters for female, 1215. So I went ahead and wrote that in. You can see the cranium size for chimpanzees is much smaller, 300 to 500 milliliters. Okay, and then we looked at, and then you can look at the rest of them. Cro-Magnon is 1600, so you're going to go ahead and put that in. So you can fill in that, and you can see kind of how the cranium size of these fossils that we found compared to humans and chimpanzees. Then you're going to be looking at the forehead shape, and you're going to be looking to see if their forehead shape is more vertical. So if you look from the nose to the eyes, it kind of goes straight up, whereas the chimpanzee, here's kind of the nose to the eyes, and then it starts slanting back. So this is more of a flat forehead, and this is more of a vertical forehead. It's not straight up and down because it's kind of tilted, but our foreheads kind of don't start sloping back like a chimpanzee's. And you're going to be looking at the other ones to see, are they more vertical like the human one, or are they a little bit more slanted back? If it seems like it's sort of a little bit of both, a little bit or confusing, you can put a little question mark, like this one looks like it's slanting back. This one looks like it's slanting back. Definitely slanted back. Whereas this first one, it's sort of in between. So you could say, you could put in between. See how I put in between for this one. So if you're not sure and it seems like it's not quite vertical, but it's not quite slanted back, you can put in between. The next thing you're going to look at is this opening where the spinal cord connects to the brain. In humans, that opening is right in the middle of the skull. So here's the skull, and it is in the middle. And so I put middle. Whereas in chimpanzees, it's kind of toward the back, the rear. Like this would be sort of the middle, and this opening is toward the rear. So you're going to look at the other skulls and see, is this opening, it's not much of a hole, but is this in the middle or toward the rear? Okay, here's that opening again. Here's the opening again. So you're going to go ahead and answer. Brow ridge is this kind of protruding bump above the eyes. So this is definitely a brow ridge, and it's continuous. It goes straight across. Some of the brow ridges might be more divided. So see how this one kind of divides in the middle? And so you're going to go ahead and put whether it's present or not present. So see how we don't really have a brow ridge. We don't have this bony thing that sticks up above our eyes. And again, if something is in between, you can put in between, because some of them are. Nasal bones are easy to see. Basically, it's this bone right here. Now, most of our nose is cartilage, so you won't see like a nose profile, but you'll see a little nasal bone sticking out, and that's the top of our nose. So humans have a nasal bone, whereas chimpanzees, they don't have a nasal bone. It's flat. So here you're just going to put if it's raised or flat, and you can look at the other skulls and you can see, like for instance, this is definitely a nasal bone, whereas if I go down to this one, flat. Chin shape was really confusing to try and figure out, so I just gave you the answers. Dental shape as well was a little confusing. So, for example, our teeth, our jaw, the back teeth, they go farther and farther apart as we go toward the back. So this shape is kind of a parabola. It's like a type of graph. It's a curve. So whereas these teeth, do you see these teeth? They're not like far apart from each other in the back. They are kind of making like a parallel lines or a rectangle. So the question was, are the other skulls a parabola or parallel? So it was a little hard to really know what to interpret these as, but these are all parabolas. I mean, to me, it looks like this is a little parallel, but I went ahead and wrote in the answers. So the rest of them are all parabolas. If you look, the back teeth do get a little farther apart versus staying close together like a rectangle shape. The incisor angle, whether the front row of teeth are angled out or they are vertical. So again, it was a little hard to know. So our teeth kind of go straight up and down unless you need braces, whereas chimpanzees kind of angle out. This one's really obvious. You can see how this angles out. But the rest of them, it was kind of like, well, is that angled out or not angled out? But I went ahead and put in the answers. They're all vertical. So these are all vertical. Canine diastema, if that's how you pronounce it, is basically, is there a gap between the canine and incisors? And here you can see there's no gap. Okay, no gap. But if you look at chimpanzee, there's going to be a big gap. You could see like right here between this tooth and the next one, there's a nice big gap. So our teeth does not have a gap, and chimpanzees have a gap between their canine and incisor, and then you can look at the rest and see whether they have gaps or not. And the last one is whether the canines protrude, whether they stick out longer than the other teeth. And obviously these are protruding longer beyond the regular chewing surface. But if you look in humans, I mean, our canines are a little pointy, but they're all the same length. They're not sticking out longer. So for us, our canines don't protrude. For apes, modern day chimpanzees, yes, their canine does protrude. And then you're going to look at the rest of the skulls and say yes or no. Okay. When you finish that first chart, Then you're going to take the first two columns of this. Okay, so this first two columns right here, all this information, and you're going to go ahead and fill it in right here. You're going to put in the cranium size, the forehead shape, the foramen magnum position, all of this, okay? And then what you're going to do is you're going to look at these species of fossils that we found, and you're going to compare it to the Homo sapien, the human, and the chimpanzee. And you're going to say, is this Australopithecus boise, which is this one down here, okay, is this cranium size closer to a human or closer to a chimpanzee? And you put ape if it's closer to chimpanzee, and you put H if it's closer to human. So A or H. So these are all going to have A or H in them. All of these down here. Okay, and the way that you're going to determine that is you have to go back up here and see what was the cranium size of Australopithecus boise. 510 milliliters. Well, is it closer to a modern day chimp, or is it closer to a Homo sapien, modern day human? Well, if I look at the numbers, it's actually closer to a modern day chimp. So I'm going to go ahead and put A for ape. Then I'm going to look at the next point. I'm going to say, oh, is the forehead shape closer to a chimp or a human? And if it's closer to a chimp, which it is because the answer is already given, then I'm going to put A. Okay. Let's look at the Homo Neanderthal. So Homo Neanderthal is right here. Okay. The reason why they put human is because this information must be closer to a human. So let's go up and see what our answer was. Okay, we didn't write the answers yet, but Homo neanderthalis is 1600 to 1650, the brain size capacity. Okay, so 1600 is actually closer to a modern day human, even though it's bigger. They had a bigger brain than our brains. It's definitely not closer to a modern day chimp, which is way smaller. Okay, so that's why under Homo neanderthalis, there is an H for cranium size. So again, you're going to fill in these first two columns with your answers from above, and then you're going to take each of these and you're going to write an A or an H to determine whether this species is closer to a human or closer to an ape as far as their results. Okay, and their results you have to look back up here. So for example here, chin shape, we did chin shape. To be human is forward, and to be like an ape is back. So all of these are back, and this one's forward. So all of these are like an ape, and this one is like a human. So I could go to chin shape, and I could put that in, and I could put ape, 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 human. Okay, so all of them were, all of them were like apes, except for humans. Then what you're going to do is you're going to go ahead and tally how many human traits and how many ape traits each skull has. Now these are already tallied for you because a human has all human traits, and an ape, all of these are the ape traits. And then you're going to add up Australopithecus boise and see how many ape traits do they have and how many human-like traits do they have. So you can sort of see which of these skulls tend to be more human-like or which of them tend to be more ape-like. And that's how scientists try to figure out where they fall, depending on which ones are closer to humans, where they fall along this evolutionary tree, as far as which ones are more related. So it's not even saying that we came from chimpanzees, humans came from chimpanzees, but it seems like there is a common ancestor that evolved on the one hand into chimpanzees, and then the other hand into kind of more human-like species. So after you finish that, you're going to go ahead and answer the questions. And if you have any other questions, feel free to text me on Remind or email me. I hope it's not too confusing for you. This is actually one of the most challenging ones, but I think after watching this, hopefully this is helpful for you.